All right. Well, I will begin with a word of prayer. Oh.
Sorry.
I will begin. Dear Heavenly Father, we thank you for this day. I thank you for these students. Again, I just pray that you'd help us use this time wisely to just wrap up any questions that remain for this semester. And we thank you for a good semester. These fun students, Lord, in your name I pray. Amen. So I'm only teaching one section of college algebra next semester. So it's kind of depressing because there's like, if it's a bad section, it's my only section, right? Like, it took me 4 sections to find a fun one here, you know?
Wow.
You guys are the fun section.
Really?
Mm-hmm.
Yeah.
Yep. I have not like targeted a group of students to refer to as like any kind of clique in any other section. So,
why are you just teaching one section?
What's that?
Why are you just teaching one section?
Oh, this is not my usual teaching assignment. So.
What are you going to be doing?
Oh, I don't know. It's a complicated question, generally speaking, but usually I teach higher level math. Okay, so, I mean, I think the last time I taught college algebra here was like 2014. But,
what's your favorite class to teach? This one.
college algebra, of course.
Yeah. Of course, our section, right?
It varies. I mean, and I one of my colleagues is like, he doesn't have a favorite course to teach. It's about the students in the class. He's like, there was an intermediate algebra class below this class that he taught once at a community college, which was his best class, just because all the students were like totally involved and they were learning. For him, that was the best class. And I tend to feel that way as well. Now, I do like more advanced classes where I, am challenged more in terms of the material, but there's still something to be gained from teaching this class always, especially if students are into it. But listen, I know this is a gen ed class for you guys, right? You're not math majors. I get it. I mean, you feel the same way about this class as I felt about, any number of classes I was forced to take. So I'm not naive. Like, I know what this class is to you, right? Now, some of you like math anyway, and so like this is a welcome relief from the 10-page essays in the whatever format you're forced to write them in, right? Hey, we're missing an essay. Why don't we have an essay in this class?
What would the essay be on?
Well, students are always like, do you have any extra credit? I should be like, sure, write me a 30-page essay on...
Oh my god.
All right, I digress. Let's talk about the solution to test 3. So that has to be this because it has the center at 0 for x. It's got to be that one. This has a vertical asymptote at -2. It has to be this one. This is a circle centered at 2, -2 with radius 4. It has to be that one. And this has a horizontal asymptote of -4, so it's got to be this one. Anyway, you guys did a lot better on this one than it was the case on quiz 3. I think, generally speaking, people did better on this one too. Not everybody. You know who you are. And so we complete the square. Completing this, some of you like factored x times x minus 20 and y times y plus 6, which is interesting, but not helpful. So we complete the square like this and like that, and then move everything to the other side, and the square root of 121 is 11, so there it is. So we're making progress on problem 3, but some of you are still just not there yet. By the way, I didn't post the solution to test 2 in Canvas. Why didn't anybody complain about this? I told you guys to study the past tests to prepare for the final. So
That's what I'm doing tomorrow.
I have 4 sections of college algebra. I was just mentioning that. I have over 100 students, not a one. Not.
Class, so we just write the solution and go over it.
Oh, that's it?
I do that.
Okay.
Yes. I don't.
Oh, it's because I did such a good job going over the solution in class. Is that what you're telling me?
Yeah.
I don't think I go, but I mean, I like what you're trying to spin there, but the thing is, I don't cover test solutions in class.
No, you don't. After that, explanation.
But you might have a future in politics. It was very good. Let's see here. So, oh, I'm sorry. That's like, you don't deserve that. You don't deserve that. You're better than that. I'm sorry. My apologies. It's like a horrible thing to say to somebody.
It's okay. I
Okay. So what I was trying to say before I took my conversation off the rails was that you guys are making significant progress here. Like there's more evidence towards a solution, but a lot of you still are not making it to the end. And like the most popular off-ramp to a correct solution by people who have at least some algebra, all right? You have algebra, you have some core of algebra, but you just lost your way in the middle. So you got to about here, and then you decided, I'm going to solve for y. So if you get to the middle of this and you solve for y, where do you go?
Back.
You don't go this way, you go that way. Yeah. So some of you solved for y and found that the inverse function is the same formula as that, which again doesn't usually happen. So you have to solve for x is the bottom line. So listen, if you got this problem wrong, do not count it out. Maybe you can get it right on the final. Just write yourself some crib notes on the formula sheet. How many formula sheets are you allowed in the final? 3 front and back. Very good. Okay. We need to close your Office apps to install the updates. No, shut up. I swear, the worst. Microsoft is the worst. Tell you what. Ever seen that like launch party of Windows 95 with Bill Gates dancing? If you haven't seen it, you should look it up. It's truly horrible. Anyway, I digress. So this one, hey, much improved. You guys are way better. As like everybody, like all the sections. Mostly I only saw right answers here. So hooray, much better. Again, this is not invertible because it fails the horizontal line test. And now some of you were like just a little bit off here. And so if I took a point off, you see what happened. Like this point here is -6, So it's going to be both on the, how do you find the graph of the inverse function? You flip the x and the y, right? So you flip x and y, nothing happens. That is a point on the graph of the inverse. So anyway, but by and large, people were pretty close to right there. Problem 5, not much to say here. Raise both exponentially, both sides base 5. 2 to the 5 is 32, which gives you 42 here. Here we take the log of both sides. Log of 100 is 2, and so we work our way to x squared minus 9. Now, some people did some really weird stuff here, but a lot of you found your way to x squared equals to 3. And some of you even found your way to x equals to plus or minus 3, and then you talked yourself out of it because you're like, well, there can't be 2 solutions. One of these must be extraneous. This is a trick. It's a trap. No, they're just both solutions. Sorry. They both work here. How do you decide whether or not they're extraneous? Well, take it and plug it back in. See, if I do minus 3 squared, I get 9. 9 minus 7 is 2. 10 to the 2 is 100. So minus 3 works just the same up in here. So there are problems where we have extraneous solutions we have to rule out, but this is not one of them. Problem 7, everybody got right. Nothing to say there. Well, I think if anybody got the last one wrong, it was like some kind of arithmetic mistake or something. If you got it wrong, you can fix it. There's much suffering here. Much suffering. Let's go through it. So 2 comes inside to give log of x squared. 1/2 becomes a square root, and the minus stays put. Then I put them together. I have x squared times the square root divided by z because that's the property of logs. This one here, I've got log of 1,000 plus log of x plus log of y squared plus log of z cubed. Log of 1,000 is 3. Log of y squared is 2 log y. And then log of z cubed is 3 log z. And see, if I had said write the answers in terms of a log x, b is log y, c is log z, then this would just be 3 plus a plus 2b plus 3c. But I did not say that. I had natural log here versus common log down here, which means that we have to do the change of base to be exactly correct there. And if you did the change of base there, you're in pretty rare error. Like there's not many people who did that. Maybe 5. So log of x is log 10 of x, right? Which by the change of base formula is natural log of x divided by the natural log of 10. That's how that goes. And so that in triplicate is why I get that formula that I wrote there. Now, this was a little bit tricky, and I wasn't really trying to do that to you guys. It's kind of like a typo that just ended up happening, but it made sense, so I left it. But I'm sorry if that like caused you a lot of confusion. It wasn't my goal to confuse you, and I have confused many of you with that, so sorry about that. I do nevertheless think it's a fair question. It's just perhaps an unexpected question, yeah? This one here, divide 2 to the other side, and then 1/2 log c is log base 3 of square root c, and then we exponentiate both sides base 3. We get a minus b equals to root c, and then solve for a. There it is. So a lot of people got that wrong. I think you can get that right if you try again. This one, a lot of people got to the e to the minus 0.3 t equals to half, and then something funny happened in the calculator or something. I don't know. But a lot of people got to here but didn't get to there for various reasons. I'm not sure why. But a lot of people, about half the class got this right, so hooray, that's good. That's actually the kind of algebra we have to do in the chemistry class or in the other science classes where we get exponential equations, right? This is exactly the kind of mathematics we have to do going past here. This is the kind of thing that actually is why this class is a prerequisite for some other things. Okay, so some of you are still not listening. When we have sum of a logs, it's the log of a product. So the log goes away and we multiply the inputs like this, all right? So you need to learn this if you're a person who didn't do that, okay? That's how we have to do this problem. And then I exponentiate both sides, I get to this. It multiplies out to give me x squared equals to 4, which gives me plus or minus 2. Now this time, the minus 2 is extraneous because when I plug it back in, it's not even in the solution set. So, I think by and large, a lot of people got 4. Hooray, that's wonderful. And then various wrong things happened to keep you from getting the 2 and the minus 1 you're supposed to here. So I'm not sure what went wrong for you. You'll have to look at it for yourself to be sure what exactly went wrong. But we should start with like f of 2 is 10 and f of minus 2 is 14. So I plug the 2 into here. I get a times 2 squared, which is 4a, b times 2, which is 2b, and the plus c. And then like the minus 2 gives me 4a minus 2b plus c equals 14. And then subtract the 4 to the other side, I get this. Then I add the equations, I get that. Okay, so I'm not sure exactly, if you got this problem wrong, I'm not sure what went wrong for you, but you should try to figure it out for yourself so you don't, because there's a good chance that this problem comes up again on the final. You know, it's not unlikely for that to happen. So you should try to figure out what you got wrong so that if I ask it again, you don't get it wrong. Now the numbers will be different, right? Like I don't ask exactly the same numerical questions on the finals I've asked on the tests or the quizzes. I try to change the numbers, but the format might be similar. Yep.
How many questions are on the final?
Oh, enough. So people keep asking me that question. How many questions are in the final? You have 2 hours, so it's about like 2.5 tests. 2.2 tests. I don't know. So 8 or 9 pages, I would say. I'm sorry, 10 pages. Was that not enough?
What?
No, the other way?
I don't think you.
He's like, it's too soon. It's like too soon.
This question is 13 questions.
My current rough draft of the final has 9 pages.
Plus. Really?
But I'm trying to get rid of a couple pages. Yep. It does have some multiple choice, but it's not all multiple choice. So the format of the final.
26 something questions. Wait,
So-
that's 2.5 tests. So that's 13 questions. That's 13 questions. 26. What's half of 13?
I think I had 23 questions on my most recent edit of it. But of course there are multiple parts. So it doesn't, and you guys always ask this question, it doesn't mean anything. Anyway, yes.
No, it's just like a good mental preparation for how many questions I have to go in for math. Like, it's like,
You should come ready to work
I am.
for 2 hours
I'm just like,
with focus.
and
Yes.
just knowing the number of questions helps me prepare to focus.
Okay.
And also,
So if I tell you,
I want to know how many
So I should tell you 30 questions, and that way when you get to the final, you'll be like, oh, only 23, and they'd be like, oh.
I like that. That's good. 17 pages.
There are 300 questions on the final. No, sorry. All right, no.
There's like 293.
Let me tell you something productive. So there may well be enough time on the final, right? If you don't get stuck on everything, if you just work the problems, and then you have a little bit of time left, a smart thing to do is to check your answer, right? And so like, how would I check the answer here? It's not complicated. Yeah, go back up here and plug the point in, see if it works, like 210. What happens when I plug 2 into this formula? I get 2 times 2 squared, which is 2 times 4, which is 8. 8 minus 2 is 6. 6 plus 4 is 10. What was it supposed to be? It's supposed to be 10, right? If I plug minus 2 in, I get 2 times minus 2 squared, which is 2 times 4, which is 8. Minus a minus 2 is 10. 10 plus 4, 14, which is what it's supposed to be, right? If you had tried that with the answer that you got, which was wrong, it wouldn't have worked, right? But I think most people who got it wrong, there's a lot of time pressure on in the semester tests. There's less chance that you actually had enough margin in your time here to check your answer, right? Now, some of you did leave 10, 15 minutes early, right? And those people could have checked their answers. So, sorry. But I don't know if that happened to you or not, but. All right, let's move on here. Problem 14. A lot of people got this right. A lot of people. Now, so I told another section this, I'll tell you guys as well. The thing that makes this problem super nice is it's just like the one in your homework. The first one we worked in your homework, right? Where we were like, wait a minute, if we add the second and the third equations, the y and the z's eliminate, and we're just left with x's. So we get x equals to 3 almost for free here. And then once you know that, you can go and plug back into the equations 1 and 2 and get 2 equations and 2 unknowns, which then you can solve by 2 equations and 2 unknowns, either substitution or elimination, whatever. But so what I told the other section was, it's very likely that I put a problem on the final which also has this kind of pattern to it to make it easy. The mean thing to do on the final would be to give you one of the 3 equations and 3 unknowns where you actually have to use the 3-step process that I outlined in terms of successive substitution, right? That would be a jerk move on my part, and I'm not planning to do it. My plan is to put a problem on the final that's like this. My current final exam has a problem like this, different numbers, but same kind of pattern, where it allows you to add the second and the third equations to cancel most of things out. Do you guys understand what I did to the gradebook? No. Should I talk about that? Okay, I can do that. So like homework total, what I've done there is I've done 200 times your MyLab points divided by 370. So the reason for this is if you go across all of the multiple homework assignments throughout the semester and add the points up, there's a total of 370 points. That was the maximum points you could earn, right? So if I divide that by 370 and multiply by 200, if you had earned 370, you would get 200 actual course points. The reason for this is in the syllabus, right, which is posted in Canvas, but also that course planner that I posted, like the first announcement, it mentions 200 points for homework, right? So the scaling of the MyLab's points, unfortunately, doesn't match up with the 200, which means we have to divide the MyLab points by 370 to make it match. And so that's one of the columns I put in your grade book is this, the homework total points. So that's between 0 and 200. Like some of you already have 200 points, which means there's nothing more for you to do, right? But if you've got like 110 points there, well, you better get on it, right? Because you got like a day and a half there, you can still recover. And so like the easiest thing to do in terms of getting points back really fast from homework would be go back and attack the ones you have 0 on, right? There are multiple students with like 0 on certain homeworks. So I shouldn't be telling you anything terribly like surprising that if you don't do the homework, then you don't get the homework points, right? Like this is just the way it is. But They are nevertheless points. And these are nice points because once you have them, I can't take them away from you, right? Woohoo! Actually, that's true of all the points that you've earned. So there's also the modified test total, which is what? So what will go there after the final exam is the following, or at least close to something like the following: 200 times the max of test 1 over 150 final exam divided by 200. So, and then, you know, plus the same with T2 and T3. Right, so like, for example, if you make 100% on the final, what's your modified test total column going to look like? 200, that's wrong. 150, my bad. So if you make, you know, if you make the final, just hypothetically, if you make final equal to 200 points, right, which would mean you have like 100 on the final, then your modified test total will be 450 points. All right, well, unless you made over 100% on one of the tests, in which case you would still keep those bonus points that you earned. There exists a student in one of the sections who made like 170 out of 150 on test 2, right? I'm pretty sure that she's going to keep that score for the grade calculation, right? But, you know, does that make sense? So this is what I mean by I'm replacing your test grades. So in order to actually make that appear in Canvas, I clicked that the test columns don't calculate towards the final grade, and this will calculate towards the final grade. So I'm trying to manipulate Canvas to show the right number as 1,000 points at the end. Yeah. And just because I don't trust Canvas, I made another column, which is total points, right? And in that column, I've recorded all of the points that you've earned with the quiz 1, quiz 2, quiz 3, participation 1, 2, 3, and the rescaled homework points, up to the point that I updated the gradebook. Right now, in a few days, once the homework is done, once we're done with the homework, right, which is what, like Wednesday night, Thursday, early Thursday morning, something like that, then I can go back and I can finalize the homework total if I want, if I have some time. Yep. So. In terms of like the total points earned, though, it does not record test 3, and it does not record the final exam yet, because when I made this modification to gradebook earlier in the weekend, I had not graded test 3 yet, right? So I hope that makes sense. All I'm really saying is that I'm unchecking the individual assignments as counting towards the final grade, and I'm just making total columns where you can see the total points that you have for homework. I have not done the same for quizzes and participation. Those are fine. They're scaled correctly. I don't need to mess with those. But the tests, it's complicated because I'm replacing your test with your final exam grade if it helps you. How many am I replacing? 1, 2, 3? As many as 3. Right. So as many as 3. So that
Final will replace all
if you do better on the final than you do on any test, then your final will overwrite your test grades. Yep.
Is that to scale? Because there's 200 points up for grad and final.
Yes, to scale, because, right, otherwise it would be ridiculous. So that's why I say the test divided by 150, I judge that against the final divided by 200.
Gotcha. Thank you.
So, yeah. So if you made like an 80% on the test, but a 90% on the final, then your test 1 would effectively become a 90%. Now, in the past, when I've done this for other classes, it doesn't typically move people's grades that much. Like on the average of the class, there's usually about a half a grade point, like a half a grade shift, maybe about 50 points out of 1,000 overall for this policy. But there are a significant, but the effect is much more significant for a subclass of students who studies hard. For them, it's the difference from like making a C into an A sometimes, or a B into an A or something like that. Like it does for the students who improve at the end, who learn throughout the course, this policy has a significant impact. And after all, I think it's more important what you leave the course with than what you do in the middle of the course, right? So, That is why I have this policy. All right, so let me talk a little bit about, just briefly, test 1. What did we do in test 1? We factored? That is true. We factored, right? Like this, like this, like this, like this. So one of the things I told the other section is, if you're a person who took a bath grade-wise on the factoring question, if this drained your resources, right? Like if you lost 30, 40 points on the factoring problem, right? You're exactly the person who should have all of these examples on your formula sheet so that you have a lifeline, right? So if you get confused on the final and you're, I don't know what I'm doing, you can take a step back, look at the similar one on your formula sheet and go, okay, this is the kind of pattern I'm dealing with, right? This is what I need to do. The numbers will be different, but I hope that if you have a good set of examples, that is helpful to you, yeah? I'm not saying that copying these examples down onto your formula sheet is the end of the studying either, is it? Not even close, right? Because that's just, that's like a, you know, that's a life preserver. You want a boat, you know? So the thing to do is to go and look at the blank copy of test 1, right? Open that up and try to do these problems. See if you can do them without looking at the solution. Come and look at your work. Did you get them? If you didn't get them, what am I missing, right? That's how you should study, I would think. That's why I post blank copies of the solution. If you're, you know, I think a lot of you are good on completing the square now, but, you know, take a step back and make sure you can do it where it matters here, because remember, it revealed to us things are prime. Also, you know, little things like I can factor x squared out of this, and then I can go forward. You know, things like that. If you forget them, if you forget that, it's just, where do you go? How do you even begin? You know, I don't know. The question I asked the other section was for this one here. If we look at this, if we look at y equals 2x squared plus 8x minus 14, where's the vertex of the parabola? Where's the vertex of this parabola? Can you guys tell me? Anybody? Y equals to 2x squared plus 8x minus 14 has vertex. Minus 2, comma. Now you say minus 11. I like that as a good guess. I mean, that's a good starting guess, but unfortunately it's not right. Because remember, the vertex form looks like this. A times x minus h squared plus k. So this k is out on its lonesome. You see what you have there is slightly the wrong pattern. See, that 2 multiplies both of these. So we have to multiply it. See, whatever the y-coordinate of the vertex is, if we think of this as f of x, we should have this, right? F of minus 2 should be equal to whatever we put here, right? And if we plug in minus 2, we get minus 22, which you can see from this as well. Anyway, the point is minus 22 is what should go here. So completing the square, it's good for what ails you. I mean, it's good for finding the x-intercepts. It's good for finding the vertex, right?
Why is h not 4? Because wouldn't the 2 multiply?
Oh no, it doesn't. It's what is you have to have a times x minus h squared. So yeah, it does not multiply. Yep.
It just multiplies.
So the h value is what makes the vertex either biggest. I mean, what makes the parabola either largest or smallest, depending on whether a is positive or negative, right? That's where the vertex is, where this formula is maximized or minimized. So I need x equals to h. It has nothing to do with the a outside. And when you put in x equals to h, what happens is this term goes to 0, and you're just left with this k over here, which is why k should be f of the h, whatever that is. Let me go on here. Our time is dwindling. So for rational expressions, what's the key thing about rational expressions is like look for common denominators, cancel out things when you can, factor whatever you can, right? How do we divide? How do we divide? We multiply by the reciprocal, right? So there's that. When we're solving a quadratic equation and it's already in completed square form, that's super nice because then we can just use the square root property. But notice that we got square root of a negative number, which gives us an I. So we get a complex solution here. This one, we don't need to complete the square for this because it's easier than that, right? We just factor, just plain old factoring. Yep. You guys had a lot of trouble with this one. I would encourage you to review problem 5 on test 1. Problem 6. What is the key bit of advice I have for you on problem 6? If you have an equation where you're solving something involving radicals, you must isolate the radical before you square it, right? Isolate the radical, then square it. That's the path to success. And then, of course, this is an ugly quadratic, so I use the quadratic formula. It turns out one of the solutions here is extraneous. Another reminder, if we're solving an absolute value problem, we should expect 2 solutions for the equation, right? You guys had some trouble with this. Just a quick reminder how that goes. We look for critical numbers, right? Critical numbers are either where the denominator or the numerator is 0. And so I list them down here, -7, -3, 5, and 8. Notice here that x plus 7's got a squared factor, and that corresponds to the fact that the sign chart maintains its sign going to the left and to the right of the critical number. The other 3 either have power 1 or power 3, which means you got a sign flip. This was the sign flip theorem I talked about. So here's your sign chart. To solve the inequality, we look for what? We're looking for greater than or equal to 0, so we're looking for pluses. So we got them here and here. So most of the answer is -3 to 5, union 8 to infinity. And then this over here, why is that there? Well, this is greater than or equal to 0, right? So if we plug in -7, it's still 0. So I have to throw that in over there. And on the other hand, why are 8 and 5 missing from the solution? See, they're excluded. We can't divide by 0. That's exactly it. So listen, if I had a problem like this on the final, and you had all of this, but you didn't have the 7 over here, I'd still give you 90% partial credit for that. You know, that's just a kind of a little nuanced part. This is more important than that 7 I was just talking about. So just a reminder, there are 2 big things you need to know for absolute value. The one is that if we have absolute value of A less than B, that's equivalent to -B less than A less than B. But if we have absolute value of A greater than B, that's equivalent to A less than -B or A greater than B. And of course, I'm supposing both of these that B is positive. So that's how these inequalities were solved. See that right here? This is my A. My B is 1, so I go from -1 less than A less than B, which is 1. And then I just solve this compound inequality and get the interval. On the other hand, this one is really different because we have two separate cases to deal with. Either it's less than -7 or it's greater than 7. I have to solve those separately, and I either get this or that, which gives me these two rays whose union form the whole solution. So a lot of you got this wrong. Well, I'm not sure a lot of you got this wrong, but overall, in college algebra, people tend to get this problem wrong in one way or another. So do review it, because it's been a little while, and we haven't really been doing a lot of inequalities lately, have we? This is the problem about parallel and perpendicular lines. What's the big idea? Parallel means same slope. Perpendicular means what? Negative reciprocal slope. So negative reciprocal. So -1 over -4 is 1/4. Let's see here. Let me go to test 2. That's it for test 1. Test 2. So as I make the final exam, I open up all of the quizzes and all the tests. That's my process. I open up all the quizzes and all the tests from the semester, and then I start cutting and pasting and changing. That's what I do, all right? I will tell you this. because the systems of nonlinear systems, like the x squared, like looking at intersections of circles and hyperbolas, the last thing in the homework, because that did not appear in quiz 3 or test 3, it's not on the final. So you don't have to worry about those. Although I would worry about those if you didn't do them in the homework, because those are points that you can get. Easy peasy, Well, relatively easily. Anyway, so this is quiz 2, which is like test 2. Remember, I made this error in the solution, which nobody noticed. But anyway, it's okay. You guys judged it in the way I'd hoped you would. Let me skip ahead here, talk about this one. So, okay, so to figure out hole in the graph, x-intercept, vertical asymptote, we're looking for matching above and below for hole in the graph. So there's a hole in the graph at 2. There is an x-intercept at -2. There's a vertical asymptote. We get division by 0 at -1. So that's why I say x-intercept here, vertical asymptote there. And the hole in the graph, where does the 4/3 come from? Well, that comes from plugging 2 into the reduced function. What's the reduced function, you might ask? Cancel out the factors corresponding to the hole in the graph like that, yeah? Now, you should definitely look at problem 4. Some people had trouble with problem 4. Make sure you look at problem 4 both from the quiz and from the test, right? They're a little bit different. Same with like the graphing problem. Make sure you study both graphing problems from the quiz and the test. They're different. And a lot of you got the problem on the test wrong because you were assuming that it would be like the problem on the quiz. And it was, well, yes, it was like it, but not exactly like it, right? So there's a distinction there. Let me focus my attention here. Factor theorem is important, right? There will certainly be a question on the final exam about the factor theorem. What is the factor theorem? It says that if f of c equals to 0, then what? X minus c factor of f of x. What's the complex factor theorem say? It says if you have a complex root of the polynomial, that's true if and only if what? X minus alpha squared plus beta squared is factor. So both of these were tested on test 2. Yeah? So the factor theorem here, because I got an x minus 1 and x minus 2, that gave me x squared minus 3x plus 2 as a factor. I used long division to divide it out and to see that I've got x minus 3 multiplying it, like that. Let's look at the next one here. Here, I gave you a complex 0 of 1 plus 2i and a real 0 of 5, which means that there was a, by the complex zeros theorem, x squared minus 2x plus 5 from this guy, x minus 5 from that guy. And that's it, because we're looking for a cubic. So if you've got order 2 and order 1, multiply them, you get a third order. And I also know that the y-intercept was 50, which fixed this a here. And then we multiply it out. Now, this is like the only problem ever, pretty much, that I multiplied it out, right? All of the other answers, did I multiply it out? No. Why? Because it's not interesting. And it would take up oodles of your time to actually multiply these out. And so like this one here, we've got a crossing at -6, a crossing at 4, which gives us x plus 6, x minus 4, but a bounce at -2, right? So x plus 2 squared, the multiplier out front. And I'm told f of 0 is minus 48, which allows me to figure out that the multiplier is a half. And there's your answer. Again, I don't multiply it out, right? Another reminder, long division. Like there should be a long division question somewhere on the final. How do you long divide and what does it mean? So if you can do problem number 9, if you're rusty on that, maybe work through that long division handout that I gave, right? I gave you 10 examples to chew on. Any questions about this here? So if the remainder is non-zero, that means that it does not factor, right? Like if this x cubed plus 2 was a factor of f of x, the remainder after you're done with the long division should be 0. And this term wouldn't be present, so you just have like f of x is equal to g of x times whatever's here. But instead we have this down here. Let me skip over to the test. So like what I was talking about a second ago, the difference between the graph and the quiz versus the test. In quiz 2, we had equal order above and below, which was why the horizontal asymptote was at -2. On the test, we had the denominator has larger order than the numerator, which means we got a horizontal asymptote of 0. So, you should understand the distinction between, like, when we have a denominator which has larger degree, the graph has to go to 0, right? That's a nice thing to know about. This one here. So a lot of you were like, I can't remember exactly, but the which ones you guys put squares on weren't quite right. So just remember, if it bounces, it gets a square. If it crosses, it does not. So here, x minus 2 gives me this x plus 2. The minus 6 gets a bounce. The minus 4 gets a bounce because they're bouncing, right? Let's see here, one other. This was a kind of tricky problem. So here I had this quartic, and I told you to divide by x squared minus 6x plus 10. And when you do that, you get a remainder of 3x minus 5. So what that means is f of x is equal to this times that plus that. And this is interesting because if you plug 3 plus I into it, the quadratic becomes 0. That is the complex 0 of this quadratic, which means all this goes to 0, and you're just left with 3 times 3 plus I minus 5, which works out to, 4 plus 3i. There does exist a student who plugged 3 plus I into this formula and just worked it out and got to this answer of 4 plus 3i, but that is certainly not the right way to do it, right? Anyway, this thing I'm talking about right here is really kind of bonus. So you can, if you don't understand what I'm talking about right now, it's not like a big deal. Yeah, that's it. So I'll see you guys at the final. When's the final?